Hello, today's video is going to be about complex numbers. Consider the number 5 plus 2i. Because 5 is a real number and 2i is a pure imaginary number, they are not like terms and cannot be combined. This type of expression is called a complex number. Standard form of a complex number is a plus bi. A and b are both real integers. This is the real part, and this is the imaginary part. When we do addition, subtraction, multiplication, and division, for the most part, with complex numbers, it's very much just combining like terms, and it's very much like add, subtract, multiplying, and dividing with variables. So you're not going to see a lot of difference initially. But as we get to some more complex problems, LOL, complex problems, complex numbers. I'm so funny. Anyway, as we get to some more difficult problems, you are going to see some slight differences because of I being a special number. Okay, adding and subtracting. The only reason these parentheses are here are to throw you off because this is a complex number and this is a complex number. But if we had a coefficient here, these would both be positive ones. And if you distribute a positive one, the parentheses go away, but literally nothing else happens. So we can just rewrite this with no parentheses. Now we can combine like terms. So negative 11 plus 9 is negative 2. 3 plus 2i is positive 5i. That is it. That's your answer. Now when you subtract, we said this was a positive one. That means this is a negative one. So distributing a positive 1 does nothing, 7 minus 2i. But distributing a negative 1 changes this to minus 2, minus 6i. So 7 minus 2 is 5, negative 2i minus 6i is negative 8i, and that, my friends, is your final answer. Now, when we multiply complex numbers, we want to remember that I squared equals negative 1. So, number 5, we're just distributing. 2i times 8 is 16i. 2i times negative 3i is negative 6i squared. But we know that I squared is just negative 1. That means this is really 16i plus 6. But complex numbers are a plus bi. So we need to swap the order of these. 6 plus 16i is our final answer. On number 7, we have two complex numbers multiplied together. Number 5 was a pure imaginary number times a complex number. In this case, it's like multiplying binomials. You have to distribute the 7, then distribute the I. So 7 times 4 is 28. 7 times negative I is negative 7i. I times 4 is positive 4i. And I times negative I is negative I squared. So we get 28 minus 3i. Negative I squared is negative 1. So this is really 28 plus 1. So we're going to get 29 minus 3i as our final answer. Now, this seems like I'm interrupting something to teach you a whole different thing, but we need to know this when we go to talk about division of complex numbers. So kind of pause in your brain and just think about this. This is a special form of multiplying two specific binomials or two specific complex numbers that give us a special product. So this tells us two complex numbers, a plus bi and a minus bi, are called complex conjugates. The product of two conjugates is always a real number. So like I said, you'll understand why this is important later, but right now I just want you to understand the cool trick that happens. When we multiply these, 8 times 8 is 64. 8 times negative I is negative 8i. I times 8 is positive 8i, and I times negative I is negative I squared. Negative 8i plus 8i is just 0. Those cancel. So we have 64 minus I squared, which is just negative 1. 64 minus negative 1 is just 65, and that's it. So we took not real numbers and turned it into a real number. Specifically because these terms matched each other and our signs were opposite. That's what a complex conjugate is. So again, for number 12, we have a 5 and a 5, a 4i and a 4i, one negative, one positive. Those are complex conjugates. Let's multiply them together and see what happens. 5 times 5 is 25. 5 times 4i is positive 20i. Negative 4i times 5 is negative 20i. And negative 4i times positive 4i is negative 16i squared. Our middle terms cancel. 25 minus 16 times negative 1 is just 25 plus 16, which is going to give us positive 41 as our final answer. So again, we took complex numbers and changed them to a real number. So when we divide complex numbers, there is a rule that I cannot be in the denominator. So if the denominator is a monomial, this means one term. As a reminder, terms are separated by addition and subtraction. So this expression has two terms. This has one term, one term, one term. Okay, so a monomial means one term. If the denominator is a monomial, multiply the top and bottom by I. So that's what we're looking at right now. We'll get to the binomial part in a minute. For now, let's just focus on monomials. So our denominator is a monomial. It is one term. So we will multiply this by I over I. Now, I want you to notice that I over I is just a very fancy way of writing the number 1 because anything divided by itself is 1. So if you multiply 10 over 2i by 1, you're not changing its value. You're just changing the way it looks because we chose a very specific way of writing the number 1 as I over I so that we can make this look like what we need it to look like. We can manipulate it into being in proper form. So 10 times I is 10i. 2i times I is 2i squared. 10i over 2 times negative 1, because I squared is negative 1, is 10i over negative 2, which is going to finally give us negative 5i. So now we have a pure imaginary number with no i's in the bottom. So let's look at 15. We don't care about the numerator, we just care about the denominator. The denominator is a monomial, so we will multiply this by I over I. So we have to distribute the I, which it looks a little backwards, but it's the same thing. 28 times I is 28i. Negative 8i times I is negative 8i squared. On the bottom, we get 4i squared. The top is going to be 28i plus 8 because 8 times negative 1 is positive 8. Negative 8 times negative 1 is positive 8. And on the bottom, I squared turns to negative 1, so we get negative 4. Now, two things need to happen. One, the order of these is not correct. So let's fix that. 8 plus 28i over negative 4. Then we need to simplify this kind of like a fraction. So 8, 28, and 4 are all divisible by 4. But I'm going to specifically divide by negative 4 so we can get this denominator to go away completely. So when we divide 8 by negative 4, we get negative 2. 28 divided by negative 4 is negative 7. So we have negative 7i. And then the negative 4 divided by negative 4 is just positive 1. So we don't have to write that. So we're left with negative 2 minus 7i as our final answer. Now is when we're going to get into binomials. Our denominators here both have two terms. So we will multiply the top and the bottom by the conjugate. And we only care about the conjugate of the denominator. So the conjugate of 5 minus I is 5 plus I. Remember, we have to multiply by something that equals 1 because we are not allowed to change the actual value of this expression. So we have to multiply the top by 5 plus I as well. So on the top, we're distributing. We get negative 10 minus 2i. On the bottom, we have to use the FOIL method. 5 times 5 is 25. 5 times I is positive 5i. Negative I times 5 is negative 5i. And negative I times positive I is negative I squared. So when we simplify, the top will stay the same. Negative 10 minus 2i. The bottom, our middle terms cancel, and we have 25 minus I squared, but I squared is just negative 1. So now we have negative 10 minus 2i over 26. Now, all three terms, 10, 2, and 26, are divisible by 2. So we can do negative 5 minus I over 13. We just divided all three coefficients by 2, and you can only do that if all of them are divisible by the same number. So this is our final answer. Number 19. Again, we're only worried about the denominator. The numerator doesn't matter. The denominator is a binomial, so we have to multiply by the conjugate, 2 minus I. We have to multiply the top by the same thing. So we're going to have to FOIL the top and the bottom this time. 7 times 2 is 14. 7 times negative I is negative 7I. 3I times 2 is positive 6I. And 3I times negative I is negative 3I squared. Over 2 times 2 is 4. 4 times negative I, or 2 times negative I is negative 2I. I times 2 is positive 2I. And I times negative I is negative I squared. So let's simplify. We're going to get 14 minus I minus 3 times negative 1. Over 4, these cancel, minus negative 1. So 4 minus, plus 3, because this is going to change to plus 3. 14 plus 3 is 17. Minus I over 4 plus 1 is 5. That's your final answer. And that is all we're doing for today. So thank you so much for watching, and I hope you have a great day.